Okay, now we're going to look at radicals and the Pythagorean theorem. So we're going to start first with the radicals. Okay, as we look at radicals, we already looked at solving radical equations in the previous assignment. Now we're going to look at how do we simplify radicals themselves. So if we start out with a number like the square root of 1 or radical 1, what does that mean? Well, first of all, a radical 1 means what number times itself will equal 1. Well, we all know that 1 times 1 equals 1. Therefore, the square root of 1 is the number 1. You notice I am doing an action. Therefore, my answer doesn't have the square root in it anymore when I can get it done in this fashion. So let's look at it. Well, let's just look at some perfect squares that we should know. We have 0 times 0 is equal to 0. 1 times 1 is equal to 1. 2 times 2 is equal to 4. 3 times 3 is equal to 9. 4 times 4 is equal to 16. 5 times 5 is equal to 25. 6 times 6 is equal to 36. 7 times 7 is equal to 49. 8 times 8 is equal to 64. 9 times 9 is equal to 81. 10 times 10 is equal to 100. Some more real common ones that you will see are 11 times 11, which is 121. 12 times 12, which is 144. 15 times 15, which is 225. And let's see, 20 times 20, that's not too hard. That's a 400. And 25 times 25, which is 625. So as you can see, there's a lot to this. Okay, those are some of the most common ones. 13 times 13 shows up often too. That's 169. So we have all these squares. They're all just perfect squares. 0 through 16, 25 through 100 here. So those are perfect squares. Now, if we take the square root of one of those perfect squares, such as the square root of 9, the answer is 3, because what number times itself equals 9? Therefore, 3 times 3 equals 9, so 3 is the number. All right? Now, those are the ones that are the easy ones because they're perfect squares. And those are what you will use a lot. Now, if you are going to go the route of college algebra, what I'm going to show you now would not be acceptable in most cases. So you might want to talk with me and I'll teach you how to simplify exact radicals that are not perfect squares. But for our class, we are simply going to use the calculator on the non-perfect square radicals. So that makes it really easy. And it depends upon your calculator as to how you will do it. I have a Casio. I really like it because it's very user-friendly. A lot of you have TIs because that's what was pushed in most of the school systems around here. And so a lot of you have TIs. If you know how to use them, they're great. I don't like it as well as my Casio, but then I didn't use calculators when I was in school. And when I finally got a handheld, I got a Casio. And so it's the one I like best. But that doesn't mean that yours isn't good. So all we have to do is figure out how your calculator works and how to do this. Remember, on tests you should not use your cell phone, so therefore you do need a calculator to do some of this. But a very simple 4-function calculator has a square root button on it, so you could use one of those too. Those are all really good calculators to use. Okay, so now we're going to look at other square roots. All right? And we will look at some that you cannot do because you haven't been able to do them. So let's look at the square root of 36. Well, 36 is 6 times 6, therefore its square root is 6. Another way to look at square root is to build a perfect square. If I have a perfect square, in this case my sides are 2 units and 2 units, the number of squares on the inside is 4. 4 is the number that would go under the square root. And what is the measure of one side of a square that builds the number 4? It is 2. So that's another visual way to look at square roots. So now what happens if we have a square root of a number which is not a perfect square? How about the square root of 50? And as I say, if you were going to college algebra, I would make you break it down. But in this class, we're going to use a calculator. So my Casio, I'm going to turn it on. I'm going to type in my square root picture, and then I'm going to type my number inside it and click my equals. And on the Casio, it will first give you the simplified form, and then you have to hit the S to D button to get the actual decimal value. And this is not a perfect square, therefore it is an irrational number. Remember, we talked about those on our first day of class, irrational numbers. Many of these square roots are irrational, and so the number goes on, but we're going to round to the 100th place value. So that's the second place, and so this number, the first 4 would be 7106 or something like that, okay? But I'm going to round to this second place value right here. So I look at this one. If it is less than 5, I just cross it off. So therefore, this is equal to 7.07. And that would be your answer. Not too hard, I hope. Let's look at the square root of, how about 70? Okay. Again, let's put it in the calculator. And we end up with 8.3666. We're going to round to this place value. Notice that this 6 here is greater than 5. Therefore, we're going to bump this 6 up to 7. So this is 1.37. So you see that rounding exercise? Be careful on your rounding. You may need to ask some questions on that. But if this number that you're past the one you want to keep is greater, 5 or greater, this number goes up 1. See, the 6 went to 7. The 3 didn't change. The 6 went to 7. And that's how you're going to do your radicals. Okay, so let's look at another one. We also will do a few radicals that are cubed roots. And I think the only ones on our papers are perfect cubes that we have here. Yes, okay. So, let's look at some cubes. 0 times 0 times 0 is equal to 0. 1 times 1 times 1 is equal to 1. 2 times 2 times 2 is equal to 8. And 3 times 3 times 3 is equal to 27. 9 times 3 is 27. 4 times 4 times 4. 16 times 4 is your 64. And 5 times 5 times 5 is equal to 125. I don't know many more of them off the top of my head. Okay? So these are your first 5 or 6 perfect cubes. So if I say the cubed root of 27, well, what is the cubed root of 27? What number times itself 3 times equals 27? It's 3. How about the cubed root of 125? Well, 5 times 5 times 5 is 125. Therefore, my answer is 5. And just like the sides of a square built a square that was the number inside the square root, the same thing would be true with a cube. If I drew a cube, there would be 8 cubes in that stack to build that perfect cube. Okay? And if I had the little hands-on tools here, I would do that and build that for you. So a square root is the result of a square. A cube root is a result of a cube itself. So that's what we would do. So you've got those. Okay? Now let's look at the next kind we're going to have. About something like 3 times the square root of 16. Well, your square root of 16 is equal to 4, so 3 times 4, which is equal to 12. Don't forget, this is a multiplication happening here. So you have to multiply what this is. How about 4 times the square root of 36? Okay, again, 4 times. What's my square root of 36? It is 6, and that is 24. How about 2 times the square root of 50? Well, we did 50 earlier, and it was 7.07, so 2 times 7.07 is going to equal 14.14. You can do those in your calculator. I will not object. Okay, so that's how we do the ones that have a number outside multiplying a radical. You simply do your radical, multiply it times the number that is outside. And now, the last part of this one will be looking at radicals that are in fraction form. How about the square root of 25 over 16? Okay, this is equal to the square root of 25 over the square root of 16. As long as it's a division, you break it into the top numerator and the denominator. Square root of 25 is 5, square root of 16 is 4. And in radicals, leave the fractions. Do not reduce. And I do not want you to use decimals on the fractions, on these. On the fractions, radical fractions, do not use decimals. Let's look at another one. How about the square root of 64 over 81? Okay? Well, let's split it up into the top numerator and the denominator. Square root of 64 is 8, because 8 times 8 is 64. Square root of 81 is 9, because 9 times 9 is 81. So 8/9 is my answer on that. Okay, we're going to stop this video, and then we're going to do one more video, and we're going to use these square roots in equations.